So hi everybody. Today we are following up on the web apps and PDF reporting project. Project number, we're for week 10. How was this one? This is our first foray into more traditional data science topics. Not cool. Yeah. So before this point, what's been happening is you have only really needed to worry about what you would call one R environment, which is your computer. So you execute R scripts on your system, and they produce output. As soon as you move, it's not too bad moving that to PDFs. Where it gets a little tricky is moving into apps, because now you have an R environment on another computer. So what you're really doing is setting up your R environment so that it sort of replicates what will happen when your script is executed on someone else's system. So we're adding a layer of kind of portability that we didn't have to deal with before, which makes this a lot more complicated. What it really, in terms of the actual code itself, this is actually a little bit easier than what we've been doing. What now is becoming important is that you have a working knowledge of the kind of infrastructure behind R, like how R works, and how it references the directories and how everything goes around, sort of implicit up to this point, but now very explicit. So we'll step through the project piece by piece so that you can see how that would have worked. How many people got a running functioning app, by the way? Half, okay. If you had most of the code, even if it's not functioning, that's still potentially only smaller errors. It really depends on how far you got. So if it was, for example, a configuration problem, then that's a minor error. Like if you had changed one thing and then it would have uploaded fine, which I think for a lot of you is probably going to be the case, then that's a small problem. But if you just gave up, that's more of an issue. All right, so we're going to start off in our regular code with all the normal stuff that we normally do. The RStudio API and this command might have given you a little bit of headaches if you weren't paying attention last time. Document context. Too many parentheses. Path. There we go. Uh-oh. Missing a parenthesis. And libraries. So, anytime that you run your own project, and this will be more important for our final project, and this will be more important for your own analyses when you're doing this on your own data. This is generally your starter environment where I'm sitting right now. So you don't necessarily know what libraries you're going to be using. You don't have any specific line numbers you're shooting for, but you know you will be importing libraries, and you know you will be doing additional analytic steps afterward. So what do we need to do? Go to PDF. The goal was to import, again, the National Longitudinal Study of Adolescent to Adult Health from the website. Wave 4, 2008 data as a tab-delimited file. You can see that I've already downloaded that into the data folder. We already have our documentation in the docs folder. I also have a blank Markdown folder, and the R file that I created is in the R folder. Actually, I skipped a step. Also needed to create those two files in, our two Markdown files in the Markdown directory. So one of those needs to be a PDF. We're going to just call this my PDF. And I also need to create a SHINee doc. And again, I'm doing that in Markdown, not in the SHINee option. And we'll go ahead and save both of those in their default forms into, very importantly, the Markdown directory, not the R directory. And we'll get more to why that's so critically important in a little bit. Week 10 PDF gen, yep. And the other, Week 10 SHINee, right? Right. Okay, so we'll come back to those later. In terms of data import, hopefully nothing that was in this section was real surprising or new. These are all things that we've done over the last couple of weeks. We're going to set appropriate working directory, import needed libraries. conduct a single regression of pregnancies, self-evaluation of attractiveness, self-reported gender, and their interaction, displaying summary model information. So that just means that we need to create a new tibble. Well, I'll use the same name that we used last time, though you could use anything you want. Grab the, what is it called? w4inhomedvn.tab file. Make sure that that works. It did not because I don't have tidyverse. Run, and good, 920 variables. Go ahead and pipe that into other things. We need to select a few variables. I'm going to rename them just because it's going to be a little bit easier for me. Attractiveness is going to be H4TR9. Pregnancies is going to be oh no, that was pregnancies, whoops. Attractiveness is H4MH8. Oh boy, mental health 8. Pregnancies is H4TR9. And gender is biosex 4, which we had last time. I think that's all we need, right? Yep. Run that. Make sure that that still functions. Yes, we have 3 variables. They're all being coded as integers. So we'll go ahead and change our gender variable as appropriate into a factor. Levels are going to be, what are they, 1 and 2? And the labels are going to be, one is male, is that right? Yeah. Male and female. And factor done. So now we have our import done. We're going to move on to, I think we don't need anything else, right? Nope. We're going to move into an analysis phase. We're going to create a statistical model. And we're going to do a linear regression of pregnancies on what? The other 2? Yep. Attractiveness. And we use star to indicate an interaction with gender. Specifying data equals the thing we just created. Display summary information. There's our ANOVA. Or not ANOVA, or regression. Make sure to do assumption checks. You could do this in a single plot if you wanted to, or individual plots. Doesn't matter, didn't tell you. You can see the QQ is a little weird. Probably would not actually want to run this, but good for our example. And visualization, we're going to take our final step. Visualize relationship as a scatter plot with superimposed regression lines to visualize interaction. So that tells you don't need to use augment. You can just look at the raw data itself. We're going to do a ggplot, health.tibble, with an aesthetic of x equals attractiveness, y equals pregnancies, and color equals gender. And we're going to add a geom smooth with method equals linear model. Oh. There we go. So now we have a plot. So all of that, I hope, was familiar and pretty straightforward. I just did it in 5 minutes. I hope it didn't take you more than double that. These are all things that we've covered now extensively: basic data import, data reformatting, visualization, modeling. This should be the easy part. Yeah. Is it also supposed to be a scatter plot? Oh yeah, I did. Thank you. Okay. So you actually see why we had those weird diagnostics. There's some odd cases up there. Okay, so anyway, specific details of that don't matter. This is not actually an interesting question. Instead, what we're trying to do is look at this report generation piece. And this is where things get a little hairy if you aren't familiar with the data science piece of this. So let's try that. So step 1, you can see copy paste your code from R into an appropriate location. So we'll grab this whole thing. We don't need anything under the YAML header. Paste. And we can go ahead and knit this just to see what it looks like. See if there's any errors that pop up. Are there going to be errors? Yeah, there's going to be errors. It just shows all the text. that's not what we want at all. What do I need to change in order to execute all this? Yep, 3 backticks and an R. Just to see what this does, we can go ahead and knit it as this version, just to check it out. You'll get this error, RStudio not running, because it won't be when you run a PDF. So that means that's why this code was right here. Remove the heading and the set working directory call. We're going to continue with the rest of that in a second. We're going to see some generation. It's going to take a minute. And doc being invoked. There we go. So now we have all of the output. Everything still seems to be running, which is a good thing to check first. We're still getting our individual plots. You could have done it as a matrix instead. We're still getting the scatter plot, linear regression plot. Very clearly not really an interaction there. So then the task becomes cleaning this up. But everybody gets to this point fairly easily. Like, it's literally just plugging the code in. And understanding that this pandoc is what's running R, which means RStudio is not relevant, is really important to this piece. Okay. So, great. So the task we need to do is, well, number one, we have to suppress all output and do not display anything from within libraries. So that means we need to separate out libraries into its own section. Easy enough. And we need to give some parameters to this R code in order to make sure that we don't display anything. And again, this is the same process as I would do with plain R. I'm just making one little change, rerunning it, checking to make sure it still worked the way that I thought it did. It's the same process. Don't just code. Don't write a whole script and then try to figure out why it doesn't work. Instead, do it a piece at a time. And you can see, obviously, the library code is still being called because this worked. Otherwise, those commands wouldn't run. But we are fully suppressing that first heading. So that's nice and straightforward. If we go into the next, add text before each block of code within heading to explain what you did. So the easiest way to do that is going to be to pull out, or to separate out each of these groupings. Actually, do we need to do something with data import? Oh, do not display output. Let's do that first. I'm going to tick this off again. I have a funny way to say that. Don't display any output, but do display the heading. So we're going to move the heading out. And we're going to say, what would this be? It's probably going to be messages since it's a read TSV. Let's run it and just see what it looks like. See if we're getting output or not. I mean, we're supposed to display the code, right? Yeah. So we're only do not display output. Doesn't say anything about not displaying the heading or the code. So great. And that's what we end up with. Now we're not getting all of those messages associated with the health_tibble import. Next, we're going to add text within each block of code within each heading to explain what you did. So that means we need to have each heading in its own block. Go ahead and change that too. At least that's the easiest way I can do it. There's actually a lot of different ways you could have approached this, but I'm just showing you what my intuition would be here. So add text before each block within heading to explain what you did. Okay, so for data import and cleaning, that's easy. In this block of code, I imported the data set from the adolescent whatever data set from some website. Great. I also selected the 3 variables I was interested in and converted gender to a factor variable. The specifics of what you type here are not super important, but I would recommend that if you are creating a PDF so that somebody else can figure out what you did using Markdown, this is the kind of approach you take. Literally just step through it. I'm going to go ahead and knit it so that we can make sure that that worked the way we think it did. But having that kind of code annotation is really useful for people trying to read this later down the road. If you engage in so-called open science initiatives, you also may be expected to have this kind of document to actually lay out everything you did. You can either do that as PDF or you can using Markdown, or you can probably send raw R files in the case of some journals. It really depends. Yeah, it's a very convenient way to get that script in, and you can see the LaTeX formatting there. So the stuff that I wrote appears right above that. And if you were really concerned about it, you might add in extra spaces so it looks a little prettier. Doesn't really matter. But all of that is up to you in creating the PDF. Did everybody get to this point? Okay. So we're going to continue adding this. In this block, I conducted a linear multiple linear regression of pregnancies on the two IAVs, checked assumptions, and examined a coefficients table or something. Doesn't really matter. And we also need to add text after analysis within heading to interpret results. So that I can just put right here. I probably want to go back to the console to remember what those analyses looked like. It looks like absolutely nothing anywhere. So we can go ahead and add that back in. None of the effects were statistically significant. And you might have added in things like F equals 4.011 with 3 and 5110. P equals 0.007 for the model, but there's a whole lot of weird multicollinearity issues, blah, blah, blah. Could have written any combination of that, yeah. And the add text after, and then we need intro text and visualization. Here we visualize the interaction using fitted values from the regression, or something like that. Rerun, reknit. There we go. And so you can see in the PDF that we ended up with this starter block of code right here. We have our comments, analysis, we have our comments, we've got all the things running. Summary model, we've got the output of the model, we have an interpretation statement right there, and then we have starter comments regarding the visualization and the actual code itself. So that, aside from the weird data processing issues, should have been relatively straightforward. Did everybody get a PDF? Yes. Okay. So where things get a little weird is when we move into SHINee. I'm going to go ahead and follow these instructions there. So the idea is to create an app that displays the final plot, but allows users to display men only, women only, or the full interaction based on whatever they specify in a drop-down menu. So there's a lot of pieces in that. In other words, users should be able to choose one of 3 generated plots based upon their selection in the drop-down memory, ensure that the dataset used as input for SHINee is as small as possible. Okay. So, at this point in your app, or in your R code, I'll actually go back to the raw R code for this, you should recognize that this environment exists in your computer only, right? So the key to giving this to SHINee, one, you could have all of this run in SHINee if you wanted, but that actually adds a lot of overhead because you're forcing, when somebody opens the app, you're essentially forcing R to boot up and run all this code. So what you do is you streamline by exporting the file as it currently exists and then re-importing it through SHINee. So right now, health_tibble contains our final information. So I'm going to go ahead and write CSV markdown for SHINee.csv. Or you can do TSV or whatever you wanted. I forgot to put health_tibble. And you would see, if you go back into our file list, that in the Markdown directory, that file now exists. If we open it directly, which I may need to jump out for, apparently I do. If we open that directly in a like a notepad type document, or there it is, then sorry, I'm confusing my computer here. If we open that up directly, you will see that all it's done is saved that kind of intermediate file into this CSV. Importantly, at this point, you should note how it's coded, because that's going to be how it's coded in the new file on import. You're going to end up with 2 numeric and 1 factor variable within SHINee. So within SHINee, we do the same thing that we did before. We're going to go ahead and cut out all of this stuff You could use it as an example if you wanted to. Get rid of that too. And then we're going to start our code by saying echo equals false and message equals false, because we really don't want anything in here to be running. I'm going to go ahead and recreate health_tibble by using read_csv for SHINee.csv. Okay, several things to notice here. This is a really common mistake that people make, is in terms of folder specification for SHINee. And there was a note about it in the PowerPoint, but I mentioned it last time we were running a little fast, so you might not have caught it. The idea here is that you are uploading, when you run deploy app, when you run that command, what happens is that everything that your R script requires, libraries and files, all get uploaded into one directory on shineeapps.io. Okay? Everything just as a clump gets sent to the same directory on shineeapps.io. So that means if you use the directory structure here, if you still refer to like .. /markdown, that does not exist on that computer. The way to test this appropriately then, and actually let's go ahead and run this so you can see what happens. Oh, I forgot a space. Or I forgot to put the R inside it. Whoopsie. There we go. If I put R inside and we run this app, you're going to see we get an error because there is no library by which to reference it. Even though we have that library installed and open in our studio, in the app environment, it doesn't exist. So I'm going to have to explicitly add tidyverse here in order to deal with that problem. Let's try again. The correct output we're looking for is nothing, right? If we see no errors, we see no anything else, that means the code has executed successfully. There's no syntax errors, but there might be what are called runtime errors, as in it doesn't give you the output you expected. So at this point, there's no syntax errors, so it looks okay. The next step then is to create the input that we need, right? So the goal for this is to use a, where are we? A dropdown, right? That is in SHINee, so we're going to have to load SHINee. And again, remember I said last time, you're going to have to load SHINee to test stuff in RStudio, but SHINee is automatically loaded in the app environment. Keep that line very carefully separated. The app environment and your computer, very different things. So we load SHINee down here so that I can look at the documentation for select input. That's the thing we're going to want. Create a select list input control, and it has all these components to it. You can name it whatever you want. I'm going to say select input, and let's call it gender. Let's give it a label of gender. And let's give it some choices of, we want it both male or female, right? And we're going to go ahead and select both by default. All right. When I run that, you see the sample script that appears down here. You could copy-paste that out if you wanted to into an raw HTML file and open it in your browser to see if it worked. That's one way to approach it. Alternatively, you can just hit run. And if it worked, you're going to see the drop-down that we wanted, which you do. So we have both automatically selected, and the drop-down contains both male and female. So far, so good. Okay? The input parameters are specified. Now, when we go back to the code, importantly, everything that exists in this R block, this chunk right now, is going to be run one time. Okay? What you have to imagine is that the R environment where this SHINee app is running is like you have opened a brand new fresh R, like you have just yourself opened RStudio every single time. There's no libraries loaded, there's no files loaded, there's nothing. So it is a blank slate. And what it will do is run every one of those commands one time and then stay open. Just like you leave RStudio open, this R environment will remain active. In fact, in the R app, if you hold that app open and you leave it in the background for like 5 minutes, you'll get a message that says disconnected. Because there's an active R environment, and if you don't do anything in the app for too long, it'll actually disconnect you from R. And the app will unload automatically. Okay? So you have to imagine that's what's happening in the background. This R environment exists when somebody opens the SHINee app. And when it exists, it runs library SHINee always, 100% of the time. Then it runs library tidyverse, and then it runs these two commands. The select input command creates output. It creates HTML, so that's what gets sent to SHINee. Yeah?
In this select input command, the input is called gender, and then the value, the gender value in the data set is called gender.
Yeah?
So if we later on we want to say, we want to filter gender equals to value. Gender equals to gender.
Well, because remember what's really happening is that's actually going to be health_tibble $gender, and this variable is ultimately going to be input $gender. So they're different genders. Yeah. Yeah.
Instead of both, I just did multiple equals true, so you can select both male and female.
Oh, as an actual label?
No, it wasn't a label, it's like an option.
An option within this. Oh, you did this guy?
Yeah.
Multiple? Oh, wow. Yeah, you could do that. That would be a little more complicated than what I'm going to do in the end. Okay. So, now we have a select input. The problem now is that we need to create some code that renders not the first time that R is opened, but every time that something is changed in the app. Okay? Again, remember, everything that's written here runs one time. We instead need to create what's called an interactive R session by calling one of SHINee's render functions. Everybody follow that? Okay, so there's a bunch of render functions. Let me show you a couple of them. Render plot is one, but we can, I think this has a list of different, oh, maybe it doesn't. There we go. You can see the bunch of them right here. Render data table, render image, render plot, render print, render table, render text, render UI. Each of these is actually really easy to use. Let me show you a real simple one. Render data table, and then health tibble. What each of these does is allows for interactive components in R. So what render data table does is it automatically gives you a couple of filtering options. It automatically gives you sorting options at the top here, for example. And it also automatically allows you to filter down here. So I can enter female and do sorting and filtering automatically within the web app. All done for you. So render data table is one way to do that. On the other hand, there's also render table, which is a different command. It will do the same thing, but non-interactively. Or at least not without the level of interaction we had before. It just gives you a straightforward table. All of the render functions are accessible to the real-time components of SHINee. So I could modify this in real time based on that option. I can modify any render element that way. They look for the input variable, and then they look for, or data frame, and then they look for values within it. So in this case, we're going to want render plot, because what we want in the end is going to be a plot. But importantly, and actually let me go back to a little more on this, why this works. What render table is expecting is that whatever code you put in there will ultimately produce a single data frame. As long as there is a single data frame being displayed at the end of that code, you will end up with it being rendered as a table in SHINee. The same is true of render plot. Render plot is expecting one figure. And as long as you give it one figure, render plot will work. So you can add whatever other code you want before that point. So the easiest way that I think you can do this particular task in this particular project, one, to use render plot, but two, is to add a filter based on what option is given. If you think about it, the filtering is both male and female, right? Well, both just means everybody. So what you're looking for is, did they select something other than both? So for other than both, I might say if input gender is not equal to both, then let's say my Tibble gets filter my Tibble, or not my Tibble, health Tibble. Health Tibble gets filter of health Tibble gender equals input gender. So what that's going to do is if I select male or female, it's going to say, well, take health Tibble, filter health Tibble on the basis of male or female. If I have selected both, it does nothing, because it's just a vanilla if statement. In the next line, I can then say ggplot health Tibble and do all of our normal aesthetic plotting. You could just copy this from the other one if you didn't want to type it all back out, which is definitely what I should have done. Color equals gender. Geom smooth method equals ln. Okay. If I run this, let's hope it worked. Oh, I always misspell attractiveness. Man. All right. And we'll step through why this works in a moment. So here's both. Here's male. And there's female. So why did that work? So if we look over here, again, remember that everything that occurs outside of a render function occurs one time and then is the default set of affairs for every time the rest of this runs. So right now, as of the beginning of the render plot, health underscore Tibble equals this final data set that we're interested in, and we're getting the input. Every time render is run, every time a render function is encountered, that state is the starting point for whatever occurs inside it. So since we loaded health underscore Tibble here, that version of health underscore Tibble is always present at the beginning of render plot. That's why I don't have to like filter and unfilter and change things up. I just have to do it the one time, and it'll filter it as required and then create the plot. Does that make sense? All right. That's it. App is done. What other ways do people do this? Yeah.
I don't understand how does it recognize both as like the two together. That's why I ended up using the multiple.
Well, so remember input $gender is literally whatever you want it to be, and here I told the values to be both male and female. So that means the value of input $gender is the word both. So here I'm just looking to see, is the word both present? And if it is, I filter on the basis of that value. Here, when we get to this point, color is not equal to, color is equal to gender, but gender is always the same because this is really health underscore Tibble $gender, not input $gender. Okay? So this is whatever you want it to be. Like, for example, I could say B, M, that should have been a B, and F. Select B. And then something wacky down here, like if input gender equals B, then health underscore Tibble actually wouldn't do anything. If health underscore Tibble, if it was equals M, health underscore Tibble filter health Tibble gender equals male, and then else if input gender. Else if input gender equals F, then health underscore Tibble filter health Tibble gender equals female, and then could get rid of that. Oh, quote. That would work equally well. The text has nothing, the text of this item up here of this guy has nothing to do with anything that you don't explicitly tell it to do. So you can use those values as direct input into other parts of SHINee. You can process them, you can change them, you can multiply. Like, it doesn't matter. You can do anything you want with those values. There's nothing inherently tying those values to anything in your actual data. And that's the key here. Let's try running that just to make sure that I didn't make a little mistake somewhere. So there's both. There's male and there's female. And you can see it's still getting color equals gender from the data set down here. And again, remember this is running in real time. So here we're reading our raw for SHINee file that contains just the variables we want already pre-formatted. Then here we are adding in an element on the web page that asks for B, M, or F. And then here I am checking for the value of that and then doing something. So it's up to you as to whether you do something like this approach. This is perfectly fine. If you did this, that's 100% correct. You could do something like this, or you could use those values directly. It's entirely a design choice on your part as to what makes the most sense to you. The way I did it before is just going to be the most concise way of doing it, at least that I thought of. But you can certainly write extra code. Like here I have an extra line of code. It does exactly the same thing from a functional perspective. Yeah.
In the ggplot command, can you explain how color should be equal to gender and not input gender? How does it know that? Then how does it know that ggplot should fit?
So ggplot, remember the AES, the aesthetic function? What this does is actually tells it to map these to variables in the data set explicitly. That's what AES does. So this is actually saying use X, health tibble, dollar attractiveness, Y equals health tibble, dollar pregnancies, color equals health tibble, dollar gender. So that's just how the aesthetics function works. Because it's within the tidyverse, in a sense. So this is not, if you put in input gender here, then that would be rendered as this. So like you would be essentially writing AES, X equals attractiveness, Y equals pregnancies, color equals B. Or color equals M, or color equals F, and that would not be a valid ggplot command. Yeah?
Wouldn't it technically be less code if you don't include the both twice and do multiple, and then set the default for male? That's what I mean. But then
So,
I think it would be the if also.
so how does it come back? I've actually never used multiple, so how does it come back as a vector?
Yeah, you don't use if or else if, and it just ends up having your graph of like male and female as options. And then you can select one or both.
Multiple equals, I'm in the wrong one. Multiple equals, oh, true. Okay. Oh, we'd have to put the whole thing if I want to skip all that other code. So I'm going to type it out. Let's see what this does. Well, that didn't do what I thought it would. What else did you change in this? Just got rid of all this? Just that? So right now I have male and it's showing both. You must have done something else if it worked.
There's also a filter in there. You filter gender.
Oh, there's a where are you filtering?
So under
Here.
I started with a health tibble type, and then in the next line, filter gender equals gender selection or dollar sign.
Ah, okay. Something like that. Actually. Always do that the first time. And both. Ah, neat. I'm not, from a usability standpoint, I'm not super fond of this, but it does look functional. If I, like from a UX kind of ideal. So why does this work? So that means that must be a vector. That must be what's happening. Let me actually try render text. I think it's render text, right? Yeah. Render text input gender. Yep. Okay, I see what's happening. So yeah, so what it's doing, if you understood how that works, I will be impressed. What's actually happening is when you specify both male and female, it's creating that as a vector of values. So what you're actually passing here is gender equals vector and then two possible values for equals. So you're having gender equals vector male comma female. So that's why that works. Although that's still the same amount of code as what I had the first time. So I wouldn't say that's any more concise. But yeah, that works too. Yeah, the only trick there would be that I would not quite characterize as a drop-down menu. But yeah, so that did work. Oh, I see. So it drops down when you don't select them? Oh, man. Okay, I gotcha. Yeah, so from my web designer side doesn't like that, but I see what you're saying. Yeah, okay, that's fine. Yeah. That also has the option to create an error when there's nothing, though. So that's not good from a usability standpoint, but yeah, that works. So one of the things you have to worry about with app development is stuff like this. You have to think of sort of the unintentional consequences of your design. So how is somebody going to mess with it that could break it? That's a thing that we don't normally have to worry about in like just vanilla R because it's just you doing the code. But here, for example, taking that approach, if you delete both of the genders, you end up creating an error, which if you wanted to use this in a professional way, you definitely would not want to happen. In that case, though, you could insert, let's see, an easy way to fix that here would be to do something like if input gender is, I don't know if blank will work, but we can try it. That might work. If it's it depends on exactly how SHINee is rendering it back. Oh, that caused it to crash. That wasn't good. Input. Oh, because input. Oh, so I see what's happened. So when you delete it, you're now getting an argument of length 0 and a crash error because when you don't select anything, this vector actually ceases to exist. So we would need to check, instead of if it's not equal to blank, we would have to see if input gender. That might work, because then it will render as true if it exists and false if it doesn't. Oh my goodness. No. Man. Yeah, I'd have to play with it for a while to figure out how to get rid of that error. But that's the kind of logic that you have to go through if you want to do this kind of app development. And, learning to anticipate those kind of things is definitely something that you learn with experience. So if you end up doing this kind of stuff, I will say that if you want to be impressive in traditional data science roles, like if you want to be, especially in the human factor space, this is becoming increasingly common. If you want to be impressive, being able to create apps that very quickly display to key stakeholders in the organization exactly what it is that they want to know based on your data analysis, like that's the skill that gets you better jobs. So understanding how to create these kind of things so that a person can play with a data set in a limited kind of way based on your specifications, but can tell a story with that, like that's the skill that you would want to work toward if you want to get further into app development. iOS 2 to a degree. I don't know that we work with as many of those contexts. The other situation where these kind of apps are really useful is in data journalism. So if you ever wanted to create, interactive apps exploring data sets you found on the internet, this is what they do. I mean, it's either SHINee apps or one of a couple of other options based on data sets that they analyze in R or Python. this is that same skill set. Okay. So, great. Publishing the app. So this is also, for actually publishing this is where things might have gone a little bit off the rails. The key to making this work is this piece right here. If you put in a path in that command, when you use deploy app, that path will not exist on the server. So remember I was just talking about how we have to very carefully differentiate between the RStudio environment and the SHINee app environment on your computer. Well, now we also have to distinguish that from the R app environment on the server that you upload it to, which are all different. When you upload it, when you run deploy app, not there. When you run deploy app week 10 SHINee.rmd, still got to use the path here, Markdown. RS Connect. Yeah. When you do this first line is critical. What it's doing in discovering document dependencies is saying, aha, well, number one, we always have to have SHINee, so hit SHINee. Number two, there's a call to library tidyverse, so we're going to need to upload the tidyverse library. 3, we need to download for SHINee.csv, so find that file and upload it. 4, we need this entire file, because this specifies how the SHINee app works, so we need to grab that and upload it. Then it does that. It uploads the bundle, that's what that is. In this case, it was 231,000 bytes. It uploads that bundle to the app server. Then it's running commands here on the app server to create the actual app. Because you actually, doing this with deploy app, only do some of the steps involved in creating an app. This does a lot for you. If you want to deploy this on your own server, you would not be able to use any of this. You would have to write your own server-side R code and all sorts of other nonsense. So it's doing all this for you in this step. But what that means is once all of these files get onto their server, they're all in the same directory. So if you have a directory path here, that's not where it is anymore. That's not where Markdown occurs. Or there is no Markdown directory if you put Markdown there. So in that case, you might have something that works perfectly fine when you hit run, but breaks as soon as you upload it. And suddenly it's saying things like data file not found, can't find for SHINee.csv, something like that, to specify that there is a file pathing problem. So that step is really critical. And that's the only thing. Like, that's the major area where people have trouble with this, is if they don't leave out the path here and they don't put the file in the Markdown directory down there. And so here's our full thing using the version we just had, and now we have an app. But all those things have to be true. If you skip any of those steps, then it's not going to work.